0 and up 0. So it'll be right here at what we call the origin. Okay, the next one would be over 0.1 and up 1. Over 0.1 and up 1. That's going to be very close to 0. My next one is over 0.2 and up 4. So I'm going to go over to 0.2 and up to 4. So just below that line, that represents 5. Okay, so on and so forth. Okay, so that may not have been in the camera, but over 0.2 and up 4. Okay, all right, moving on. C is plot the graph, describe the motion. So how would you describe this motion? Okay, descriptions of motion are things like speeding up, slowing down, constant velocity, accelerating. So any sort of word like that you can use to help describe the motion and put that in a complete sentence. Draw the motion diagram. Now this was a car moving across a table, I believe. So a motion diagram that would be appropriate would be drawn, let's see, like this. Okay, if it's moving across the table, it's moving along the x-axis. Okay, and let's go ahead and we don't know where it starts. The velocity up here on this graph starts at 0, but that doesn't mean the position was 0. So we'll just arbitrarily determine that we want it to start at the origin. Okay, and then go ahead and finish that. Determine the acceleration. Well, slope of xt gives velocity, slope of the vt gives acceleration. So acceleration will equal the rise over the run. And rise over run is equal to the change in velocity over the change in time. Okay, so you can do the triangle method to do that. You can do, y2 minus y1 over x2 minus x1. Okay, all right, next side. Okay, very similar situation here. You can read along with me on your paper. On a fictitious distant planet, Amethyst, so that's a fake planet, an astronaut drops a rock from a tower while her friend records its position, or its location, every 0.2 seconds using a video camera. So just to put this in perspective, 0.2 seconds would be 20 hertz. Okay, last time we did 10 hertz, so it was 0.1 seconds. Here's the picture they got. So here's the picture off to the left from that camera. The first spot is taken to be time equals 0, where its velocity is 0. So you're going to use these 3 columns here to set up the same exact data table that we had with time, position, and velocity. Okay, the time intervals were 0.2 this time. Okay, or 20 hertz. All right, where do you get the positions from? Well, this camera over here has, it says position marked every 0.2 seconds. And so it has all these positions along the left-hand side. So you've got a position of -4, -8, -12, -16, and -20. And now some of the dots line up, some of them don't. So you kind of need to determine what you think the position is. Remember, this is a picture right here. Okay? And so this is like having a ruler along the left-hand side. Alright? So you can take those values right off the picture. Okay? Over here on the right, then you're going to generate a YT graph. Okay? Which is a position versus time graph. Sometimes it's an XT if it's a car moving along the X or the horizontal axis, and sometimes it's a YT if the object is an object that's falling, okay, on the vertical axis. That's what we have here. Alright, so that takes care of B, draw the position time graph. C, calculate the average velocity during each time interval and add velocity time data to the data table above. Alright, you're going to do that. That's this right here. Okay, the same method we used on the previous side. And then draw your VT graph. Again, plot those points, velocity versus time, just like we did on the front side. And then letter E, from the VT graph, calculate acceleration of the planet. So same exact method as we did on the front. Alright, best wishes, guys.